Right. Good evening once again, ladies and gentlemen. Allow me to greet you again. Yes, in the name of my Lord and Savior, Christ Jesus. Yes, I am excited for today. I've been waiting so long for this time. And yes. This today, I decided to do the grade 12 geomorphology topic. And again, this is uh, yes, this is on the subtopic fluvial processes and landforms. Right. I know that this topic is one of those topics that are generally um, difficult to most of our learners. But I believe that today's lesson would add to your understanding. And yes, you are allowed to post your questions as I am live. We'll continue and try and answer a few of your questions. This topic is long by itself, and I would advise that we I would advise that you pay attention, and the video would still be on for some days so that you can also be able to revise on it. Um, all right, let us look at the objectives, meaning few things that we need to learn from this topic. Ne? So we're going to look at the river profiles. We're gonna talk again about the river grading. We're gonna talk about the river rejuvenation, as well as how to identify these profiles and describe and how do they form these landforms. We will also discuss the concepts associated with river capture or stream piracy, as well as features associated with the river. Ne? But in this tonight, I'll be focusing mostly on the first topic. Ne? I mean the first point, which is river profiles, river grading, river rejuvenation, as well as the identification, description, and formation of these fluvial landforms. Remember, if you have any question, just type in the comments, and then even if you like it, just type like and share as well. Now, let us start. River profiles. Now, on the river profiles, we are referring, the view of the river channel, e.g., viewing across the channel and along the entire length of the river from the source to the mouth. In other words, we are looking at a river from where it starts and up to where it ends, right? So that is a river profile. Right. Now, I've just given you a few pictures here. If you can look, this is a picture of a river profile. Ne? Remember that we have a longitudinal and a transverse profile. So look at this one that I've put here, this picture. So over here, we are having a longitudinal profile. You are able to see from where it starts from the source and then going down to the mouth. Ne? And on top here, where you have your A, B, and C, you are having it symbolizes your transverse profile. Now, where it shows you certain parts of the river, whereby you have, we're gonna talk about them. That is where it starts in the middle course, the upper course, the middle course, and the lower course. Ne? Right. Now, the long and the cross profile. Long for longitudinal profile and the cross for your transverse profile. Ne? Now, the matching cross profile with different stages of a river and then different temporary bases, we also have the rejuvenation. Let us look at this now. This one here, it shows us the longitudinal as well as the transverse profile of a river. And I want us to dwell for some time on this one. Ne? And the way I've put them is so that you could be able to understand, so that you could follow, and I believe it would also make much sense as well. Now, we have the upper valley, we have the middle valley, we have the lower reaches. So in other textbooks, that would be your upper course, your middle course, and your lower course. Ne? Now, I want us to try and then read step by step. Ne? Now, let's focus on the upper valley or the upper course. Now, in the upper course, that's where we're going to have your source, where your river starts. Ne? That's your source. And now, even if you can, let's look at the longitudinal profile, the way it is. Now, you can tell just by looking at it that the gradient here is very steep. And therefore, if the gradient is very steep, you should now understand that water would flow at a very high speed. Water would flow at high velocity. And therefore, if water would be flowing at high velocity, obviously you would know that we're going to have the erosive power, like erosion would be there. But nonetheless, in this stage at the upper valley or the upper course, you have what is known as the vertical erosion. In other words, vertical erosion means that water erodes vertically, meaning going down. That's how water would erode, and therefore it means it will dig down, going down. And in most cases, that is where you will have your waterfalls and so on. So momenti awelang for thing, there's that erosion. Let's look at what we have here. It says vertical erosion with hydraulic action, abrasion, and attrition dominant process. Ne? Then the point that we have again is that the load size is large and angular. Now, I want us to compare this with the cross profile, the transverse profile. Ne? Now, when you look at the top there, in your cross profile, if you are looking at that river in a cross profile, you would notice that it gives you a V-shaped valley. It is not so wide. It is a V-shaped valley. Now, that is in the upper course. And that valley, it is steep, it is deep, and it is narrow. Get that again. It is deep, it is steep, and it is narrow. I hope you got that one. Ne? Now, from the upper, now we move to the middle course or the middle reaches. Ne? Now, in the middle reaches, now you understand when you look at the longitudinal profile, now you compare the gradient. The gradient now is no longer that steep as in the upper course, but now the gradient is a little bit gentle as compared to the upper course. So if it's a little bit gentle, now this tells you, again, you can just think generally out of the box that even the water movement is no longer as fast as it was in the upper course. Another thing, you understand that even the erosive power is no longer that strong, just as like in the upper course. Okay? Take it like this. They say when you are at an elevated level, let's say you are at the top of a house. When you fall, too much. But if you are on top of a table, when you fall, even if you get hurt, your head is not as compared to that one that's in a upper level. So this also should tell you that okay, we are in the middle course, therefore erosion is not higher as compared to that one in the upper course. Now the channel is deeper and wider here. Let's look at that the cross profile at the top. Now you see it is wider, it is deeper. Now it becomes more shallow as well. Now remember this, if now it starts to be wider, then what happened? It means now we start to have the lateral erosion. Erosion now takes place from side to side. That's how it is. Erosion takes place from side to side. So if the river erodes, it would erode also in the sides, no longer vertically like it was doing where in the upper course. Now the point that we have is a vertical erosion decreasing in importance. So it might still be there because of the gradient that is still there. However, it is not strong as it is. Then now we have the lateral erosion. Now the river starts to erode on its side. Now the load becomes smaller and less angular. Now remember, the load we are talking about, those eroded materials and whatsoever. Now it becomes smaller. It is no longer that much. Then we now go to the lower course. Now in the lower course, now it is closer to the ocean, and the ocean, that's why we say now is the mouth. That's where now it would release like the metia fella kote. Now in the lower course, we now have a wide and nearly flat channel. It is a wide and a nearly flat channel. Now what you have here, again, I would say to you, be in a position, check again the gradient. When you compare the gradient in the longitudinal profile, you would see now that your gradient now is a lot more gentle. It is no longer almost flat. It is not uplifted on one side and whatsoever. So now if you are to talk about the speed of the water in this level, now the speed of the water is very slow. Now water won't be moving at a high velocity. Why? Because the area is relatively flat. So take it like this. You are having a tennis ball. Now in the upper valley, you put it very steep. When you put that tennis ball and it goes down, because of that high gradient, the ball would move at a faster pace. Then in the middle course, you reduce the gradient, you put the ball again at the top. The speed now would decrease. Now going to the lower course, put the table now flat and try to put the ball. At times, it would seem as if the water won't be moving, but then because of the pressure, it will still move, and eventually it goes where? To the mouth. The mouth, that is your sea or the ocean. Right, let's focus on the longitudinal profile. On this one, ke tlo feta fastenyana because it's more of a repeat of what we were looking at in the previous picture. Now it shows the river path from the source to the mouth over the longitudinal profile of a river. It is steeper near the source which is at the top, where there is a lot more material for the river to cut through and reach its base level. Now, as you go further down the river, it has cut further down towards base level and is beginning to cut laterally, which is your sideways again. We are now somewhere in the middle course. The slope angle of the river decreases. I've been talking about the gradient from when I explained it. By this time, you reach the lower stage of the river. By this time, you reach the lower stages of the river. It almost flows over a flat surface as it meanders its way to the sea. So when we say it meanders, it means it will go side to side. And the transverse profile, it shows you a cross view of a river from bank to bank, from your upper course to your middle course, going down to your lower course. Now, the transverse profile of a river channel changes throughout the course of the river. In the upper section, the channel tends to be quite narrow. You remember that V shape that you saw in the picture? It is narrow, it is steep, it is narrow, and it is deep, and comparatively deep. The bottom and sides are littered with many boulders and rocks. Boulders, those are your big rocks, and causing a great deal of friction for the water flowing past them. This slows the water down and means that this is where the river is flowing the slowest. Now, that is when you are at there. Now, in the middle course, the river has a wider channel as compared to the upper course, which is deeper than the one in the upper reaches. And the water flows faster as it has less material to slow it down. The river may begin to meander, meaning in the middle course, your river would start to change maybe direction, going sideways. Remember, we said in the middle course, now it starts to erode on the sides. So as it meanders, it goes from one side to the other. So, that's how it is. The lower course sees the river flowing at its fastest until it slows down when it meets the sea. I hope thus far you've been flowing with me. Now, the river grading. River grading is the state of balance or the equilibrium between the rate of erosion and the rate of deposition. It can be used in two ways: the graded river and graded profile. Now, a graded river, here the river has just enough energy to carry its load. Neither erosion or deposition is occurring. So, in other words, it means that the river has just enough energy to keep flowing. And as it flows, there's no erosion that is taking place. There is no deposition that is taking place. Let me repeat that. In this stage, the river is just flowing. Ne? And as it flows, it doesn't erode, it doesn't deposit anything. Ne? Remember, we have your deposition, we have your erosion as well. Now, the graded profile is a smooth concave profile with a steep, or which is steep at the source and gentle at the mouth. It takes us back to that picture in Ernalion, the one that I've been using in explaining this. So if you can look at that picture, you would understand that that profile was just concave. Ne? We did not have any nick points present and so on. In other words, it was just flowing like that. Now, if we can have the graded profile, we can have the ungraded. Yeah, it means if we can have the positive, we can have the negative. Right. Ungraded profile is a river profile that has irregularities, obstructions, or temporary base level along its path. You know, now you're gonna have your nick points, and generally our rivers are ungraded as compared to them being graded. You know, they are ungraded. Ne? Now the ultimate or permanent base level. This is the lowest point to which a river can erode. And usually the permanent one that we have, that is your sea level. You know, it is believed that in a sea or in an ocean, water cannot erode any further downwards. That is why we say that is the ultimate or the permanent level. But if ever it's not in the sea, what happens is that it would keep eroding. It would keep eroding. Ne? Then we have the temporary base level. Yes, if you have permanent, you've got temporary. Now, temporary base level is a point along a river course that prevents it from eroding any deeper at the moment, but may be eroded through or change in time. So, at this point, in temporary base level, it's like, no, you cannot erode me any further. Like, I'm here, I'm stuck, you're stuck with me. But then that base level it also becomes eroded. Ne? That other one. I'll be with you forever. But then right. Let's look at the graded profile. Look at this picture. You have your source there at the top. You have your mouth at the bottom. Ne? And now, the smooth concave profile and is decreasing in angle and gradient towards the mouth. So if Wailebella is just so smooth, you know, there's no obstruction. If water was to flow, it was just going to flow without anything obstructing it. So that is the graded profile. Ne? And then born at the source, usually it is very steep, it is deep, I get, and very narrow. There it is. Ne? Right. The ungraded profile. Now, check the difference now. we are there now at the source, which is at the top there. Ne? Now, Otamaya also onale the disturbances. If you can check here, you have your nick point, there are those rocks and whatsoever that are disturbing. Then it is not straight if you look at it. Then again, it is not smooth. It is not that concave. Now, waterfall erosion will exceed deposition. Now, in other words, waterfall. Okay, let's take it like this. In a waterfall, let's say your water, it's flowing. Then when you are here, you see it has changed the angle. But now going down, the angle here and the angle here are different. Now, if the water is to go down here, what will happen here? We're going to have a lot of erosion. That is why we say waterfall erosion exceeds deposition. Now as the water we have that erosion here, the deposition becomes less, and it's a mafela yalo going down, just like that. So it is not smooth. Ne? And then you look at this white line that we have, ne? The one that divides your road. You now get to see, okay, that is a possible graded profile. Possible. It might not be there, but it's a possible one. That, okay, at the end, a graded profile, it might go through that line. For some of us, when we were still kids, we used to go and then swim at a river. And you would understand that in the river, okay, we swam, in the lower course or the middle course, whereby now the river is meandering and whatsoever. But you can still tell that it is not level, it is not graded. Some of you who could have once went to a river, they would know this. Right. River rejuvenation. Now, to rejuvenate, in your English class, I believe they've taught you that is to give strength again. Now, the river gets rejuvenated. Now, it occurs when the energy of a river increases. And usually, when the energy increases, we're going to see that through the speed. Now, the following rejuvenation can occur due to the following factors. You have three factors. Yeah, you have your isotectic change, static change, and you have your tectonic upliftment. Now, under the isotectic change, here the land rises in comparison to the sea. Now, remember that a river is found on land. And then it moves where? It moves towards the sea. So now if the land would rise somehow, if the land goes to be at an elevated height, and that's where we have the river. Now it means that the river would now increase its speed going down. But if ever it was somehow closer to the sea or the ocean, therefore it would be slower. So remember, if the land rises, if the altitude rises, the land, then we're gonna have the river gaining energy. Eustatic is caused by the change in global sea levels, which is linked to the changing temperature of the Earth's atmosphere. In warmer periods, ice melts and the sea level rises. And then in cold periods, there is more ice, sea level, and then there is in cold periods, sorry about that, there is more ice, sea level would drop. Now, let me explain this. If ever ice would melt, it means that as it melts, it goes to rivers. The rivers get what? More water. Then it does what? Then it would also increase the energy or the speed of the river. And in this one again, we also include, like we've said, the change in temperature and climate. So it would also include in rainy seasons, you end up having what? You end up having rivers flowing at a higher speed. Ne? Why? Because of the small water. But in dry seasons, what will happen? The river would lose energy. Then the last one that we have here, that is the tectonic uplift. Here the plates move due to folding, causing the land to rise in relation to what? To the sea level. The topic about the faulting and the folding was similar to grade 10, waya ko yona ko 11. Now again, it is here. If ever we have such things, if the tectonic upliftment occurs, it would cause the land to be at an elevated position, and then giving us what? Giving us a rejuvenated river. Remember, the land where your source is, if it is higher, then you have more energy. But if it's lower, closer to the sea level, then the energy is also lower. Simple, ne? Right. Now, rejuvenation. Let us look at this picture. Ne? You have your source, you have your middle course, you have your lower course. Ne? Now, we have the original graded profile, we have your first regraded profile, and the most recent graded profile again. Mabana yanong re thoma re linka yanong le river grading and whatsoever. Now, we start with that top one that we are having. Ne? So here at the top, here, it shows you, okay, the original graded profile. So the river, and then it was just flowing just like that. And then, already it was going to the sea. That's how it was. But now, because of rejuvenation, as it becomes rejuvenated, now it regains energy. If it regains energy, it also regains the erosive power, meaning it can erode, it starts to erode more. Ne? Now, it starts to erode again. Now, if you can check here, now we have another thing. Now, that would be your first regraded profile. Remember, why do we say regraded? It's because we had what? Our graded profile. Now, the level now starts to change. So okay, let me put it this way. At first, all here, it was maybe some piece of land and whatsoever. That was the original sea level. Then as it becomes eroded, now it erodes, then the second part would also move. then now we're going to have another sea level. That is where it is, you know. Okay, let us look at this. Far you have, it says to you, the original sea level, ne? Which is your original, on your original graded profile. Now, the sea level dropped, ne? As the sea level dropped, it came here. Then what happened? It caused here to do what? Now the land was higher. Land was here. The land was higher at a higher altitude in relation to what? To the sea. Then, if remember what you said, if ever the land now becomes higher, rejuvenation takes place. Then erosion would take place. Then it's coming here. Now, if again the land becomes higher, or perhaps the sea level drops, now the same thing would happen. We're gonna have again that thing, getting rejuvenation, erosion takes place, then again it goes. Hence, we have the most recent graded profile. So it means again, if ever this here, we can have the sea level dropping again, we're gonna have what? Again, something similar to what was happening here. Erosion would take place again. Right. You know, if I was in class, I would say, any questions? Right. Then the landforms. The landforms resulting from rejuvenation. Landforms resulting from land rejuvenation. Okay, before I see a question here, why is there an ungraded river, and what actually causes both graded and ungraded? Okay, Pablo, remember this, ne? I said generally what we have is the ungraded river, ne? And that is because of the change in times. Most of the rivers that we have been there for a long time, and therefore, if you also consider those things, we've been having different, change in temperatures and so on. And if we have change in temperatures, so on and so on, you find that water level would decrease, no erosive power. If we have rejuvenation again, it would erode, changing the landforms and so on. That is why we end up having getting the ungraded rivers. And remember, like I said, it's very rare to find a graded river at this point. So in other words, I think this is more to say, at first we had a graded river, but as it flows, as we have changes in the sea level and so on, it started to do what? To become ungraded. I don't know if I did answer you very well. I'll see by your comment. Right, the landforms resulting from rejuvenation. First one, we have a nick point. The second one, we have incised meander. The third one, we have the terraces. Now, on the nick point, a nick point is a sudden break in the profile of a river where the gradient increases, e.g., the temporary base level. Let me just take you back to the previous slide. Yeah. Now, when we look at this picture here, we had your original graded profile. Now, it means that the first what is it? We had your temporary base, it was here. But then when we had when river rejuvenation occurred, it eroded what? It eroded the temporary base. Now we have the nick point here. Now it came here. Again, we had a temporary base, which was now here, meaning that this land was now here. Ne? Now it is also a temporary base. Remember that we say the permanent base that we have, that is of the ocean or of the sea. Now, when rejuvenation occurred again, we start to have what? We start to have another nick point. Now, when you check here, the gradient does what? It increases. And if it increases, you're going to have your waterfall, and then all these things will take place. Right. Incised meander. Here, a river meanders across a flat plain in the middle or the lower course. When rejuvenation occurs, the river erodes vertically and the meanders are cut deep into the landscape, forming incised meanders. Now, remember that, okay, this one we say in the middle course, ne, or the lower course. Now, remember, if ever rejuvenation takes place, ne, it can take place maybe because of the land, because the land went to a higher level, ne? And as it went to a higher level, obviously erosive power. And if ever we have a change in the gradient, it means now it would start to erode vertically. Ne? We have a waterfall. So if we have a waterfall, waterfalls erode vertically. Therefore, in those meanders, meaning as your river goes to your left and your right, we're going to still have those ones that are cut deep, meaning erosion is going deep down. Thank you, Babalo, for understanding. Right. Now, the terraces. A terrace is the remains of previous flood plain. The river has cut through this previous floodplain. The past floodplain is at a higher level after the river has been rejuvenated, and it forms terraces. Then lateral erosion by the river will cut the terraces, forming paired terraces. This process can be repeated several times. Now you'll be having a floodplain, meaning, okay, this is where the river was. Then as the river starts to cut deep down, it erodes vertically, then again. Ne? And then in that erosion, now we start to have, maybe let's say time goes on. Now the river would be flowing at a lower level now, but we still have those floodplains, the previous floodplains, which are at a higher level, meaning that it was eroding vertically and not laterally. And then as time goes on, the river might go again, erode laterally, laterally, meaning sideways, and maybe in the long run, they may end up falling. These are some of the pictures, but we've dealt with that. When you look at this picture, now it was somewhere here, then we have a nick point, then we're going to have a waterfall. Now, if we have a waterfall, the speed of water here is much higher. And if it is much higher, obviously it would cut vertically. It would erode going down here. So the previous floodplain still remains. That's how it is. Right. Now these are your meanders. The river just usually this happen in the middle course or the lower course, but then river rejuvenation occurred, then it cut deep, and then you have your incised meanders. Now, this one explains the third one, the terraces, whereby you have your past floodplains. Now, let us look at this. What does this mean? We are here at the oldest floodplain. Now, this is where the river was, not Kofatiana. So all this here was a floodplain. Your water or your river was just flowing at this point. Now, when we have river rejuvenation, it starts to cut where? It cuts vertically. As it cuts vertically, now it cuts vertically. Now you're gonna have the second floodplain. If rejuvenation occurs again, it starts to cut what? Vertically again, then you have your new floodplain. And same thing, if the process occurs again, you start having what? You start having same things. It's not more like your stairs. You going down the river, but there are the stairs and whatsoever. Now, these are the previous floodplains. They remain at a higher level. But then, let's say after some time, we don't have rejuvenation. It continues to flow. So if it flows, now it starts to cut on the sides. What are you gonna have? At times you will have something like whereby you see the it would cut laterally. So when now you would be standing at the top, perhaps here, but underneath the river is flowing, like directly under where you are standing. Meaning that if it can be weak, it can fall down to that river. I hope you are still following. That was for the terraces. We've spoken about a nick point, that it is a sudden break. It's that one. And then you have it again here. You've seen the two pictures. Then the incised meanders. Here a river meanders across a floodplain in the middle or the lower course. But when river rejuvenation takes place, it cuts or it erodes vertically. You see, so on this picture, you've also seen it. The river rejuvenation occurred, and then it has cut vertically. So meaning before river rejuvenation was there, chances are it was just somewhere not deeper where it is. And then at the sides you have your your previous flood plains, and then your terraces. This is the one that I was explaining over here. Right, I think this is the identification. Yes, should be the last one for today. But I believe I'd be also doing the river as it meanders and so on, the landforms. Now, the identification, the description, and formation of fluvial landforms. Right. We have a meander. A meander, Leona, is a landform. So a meander, a loop-like bends that the river makes in the middle course. It develops as a result of an increase of lateral erosion, which allows the river to cut into the sides of the river channel. Now, a meander, you'll always find it in the middle or the lower course. Ne? You won't find it at the upper course. Remember, at the upper course, you have vertical erosion and not lateral erosion. Ne? On the outer bank of the river, the channel, of the river channel, the river flows faster, resulting in erosion and an undercut slope, and on the inner bank of a river channel there is more deposition, resulting in a slip-off slope. Now, usually when I explain this one, I would say, look at your elbow. Ne? You know, la re shapa current akere. So how sharper current looking like in your elbow, you know, I get a labona recently a president Nalbonsor, you know, current, but another you must sneeze inside. Ne? So what happens if you are in a fight, perhaps? Are you going to beat someone with the outside of your elbow or the inner part? You will use the outer part. So on the outside, ne, the river channel, it would be depositing. You know, you are using your elbow to hit. On the outside, you are eroding. There's erosion. Now it is eroding on the outer side. But on the inside, there is deposition. So when I have to try radio, you know, lifting up many things. You at times use the inner side of your elbow to what? To do what? To carry other things. Now there's deposition inside. Get that? Korawe hopola e meander. Remember your elbow. Now in your elbow, on the outer side, you are having erosion. You know, that's what you use to destroy. And in your inner side, that's what you use to carry. And you have your deposition. Let's look at this picture. Now, in this picture here, let's study it perhaps on this one. Ne? Now, this is your inner side. This is your outer side. You know, the outer side of your elbow is this side. The inner side is this one. So as the river flows, it's coming. So now on the outer side, it does what? It erodes. So as it erodes, it would grow. Remember, it erodes laterally. Ne? It hits on the sides. Ne? But inside here, what do we have? Deposition. That's where you have your slits and so on. Ne? Same again on this one. If your river comes, it is flowing. On the outside, it does what? It erodes. And then on the inner side, we have deposition. You know, it erodes. Now on this side, you have deposition inside. So even this one on the left side, it shows exactly that. Now, this is your elbow. You know what? Current, there's erosion this side, and there is deposition inside. When you come here, again, this is your elbow. Ne? You have what? You have erosion on this side, and you have deposition inside. Please remember that one. Do not forget it. Again, this one, it shows us. Now, the river is flowing, you know. So as a start, it's similar like LA straight. And then as time goes on, you know, it changes direction. Now, remember, Kafa, it would erode. Then it comes, Kafa, it erodes, you have deposition. You know, it goes, you have erosion, you have deposition inside. Then, as time goes on, it continues to erode this thing. Now, it erodes further. Now, meaning it starts to curve a lot now. Then you have your deposition again. and then erosion on the outside, just like that, up until now you see a river being different from the way it was years back. Ne? Now we have what is known as an oxbow lake. An oxbow lake is a horseshoe-shaped lake, or a horseshoe-shaped lake that forms when a meander bends in, or a meander bend is cut off from the main river. This can occur when the river comes down in flood and cuts through the neck of the meander. It then deposits sediments on the sides of its bank, cutting off the path of the meander. Now, let's look at this. The first image, what we are having, remember that thing of erosion, eroding, and then deposition. Ne? Now, on the first picture that we have, it's eroding. Now, where you have your arrows, that is your area of erosion, and where you have those circles, that's your area of deposition. Now, as it erodes, look at here. As it erodes, it erodes, it deposits inside. We come here, it erodes, and even this side, it does what? It erodes. But kafa, it does what? It we have deposition. And then on the sides as well, it does what? It erodes. But then, and at the end, if you can look here, there's erosion taking place, there's erosion taking place. So eventually, what will happen is that these parts would do what? Would meet. And then here we're gonna now have a new stream, and we're gonna have the abundant meander or an oxbow lake. Now, this part here is this part. It was cut off. A picture of that. You're looking at this river. So you have here that oxbow. And then at the end, this thing, perhaps it was just like that. It came, this river came, it joined, it went like this. But as erosion continues to take place, and there was also deposition, erosion, deposition, we end up having a new stream. Right. There you have another picture there. Same thing. And then the braided streams. I'm now about to conclude. It occurs when the river gradient becomes gentle and loses energy and deposits its sediments, creating sand islands above the level of the water. So now we're telling if it's something like it's a tree, on a santa there and there. Sometimes even in a river, after some time, as the river flows, it seems like the other part of water goes to the left side, the other one, and then they meet again. But more for the scent or whatsoever, braided streams. That's what we are talking about. The river cuts through the sand islands via many small shallow channels, which recombine after it passes the sand island. This is what I was saying. The channels are called the braided streams. Now, when I get to school, and you are more likely to get your question paper in black and white. So you should understand this picture on the left. Now, you had your river flowing and whatsoever. And as it flows, these are your Bantu those sands, as and then on this white part here, that's your river. Now it comes again to do what? To rejoin after these sand islands. That is that. And then far on the right, you see that picture. This is your water moving. And on these green spots, that is where you have your sand islands. Ne? So it's like that. Floodplain, as the river nears the lower course of the valley, is wider and the gradient is gentle. We've spoken about it at the beginning. At the lower course, the river is wider, the gradient is gentle, almost flat. The flat area on either sides of the river channel is the floodplain. During times the floodplain during times of flood, the river overflows its banks, depositing alluvium, hence the name floodplain. And that's the picture. We have what is known as the leve. During the flooding, the corset and heaviest materials are deposited alongside the river channel, forming natural ridge or embankment called a leve. Men sometimes elevate and strengthen these levees to protect settlement. Now is this. Here's your leve here. So at times, just to protect the settlement, they strengthen this so that it doesn't erode any further. So it was here. As it erodes, then they start, okay, this is the floodplain. Then they do what? They strengthen it so that even if it floods again, it doesn't goes even wider. It rather goes down and so on. And then the settlement becomes protected. That's all for today. Guys, thank you for watching. Thank you for watching, and I believe that this presentation was good and you have learned a lot. And remember that you as a grade 12 learner, you are still going to write about everything. Ne? You are going to write about all these things. So thank you guys for watching. Have a blessed afternoon.